All right. Can I make someone co-organizer? Okay. I'm making Yogesh co-organizer. All right. All right. So let's start for today. And do you have any questions before we start our discussion? Okay. So the first question from Kulvi is that what's the difference between HBase and RDBMS? Okay. A question from Ila. Okay. All right. All right. Great. So let me try to answer these three questions and then we will continue our discussion on pig and piglet. All right. Feel free to ask if you have any doubt. So first question is, what's the difference between HBase and RDBMS? Okay. Honestly, we will discuss it in detail when we talk about HBase. A quick answer is in RDBMS, there are a lot of constraints imposed by the relational the relational structure. Okay, while in a HBase you don't have that many constraint. Okay, the important aspect about HBase is that you can create as many columns as you want. Second, you can create as many rows as you want, and there is no data type as such of a column. And in case of HBase, the server runs on top of Hadoop. Servers run on top of Hadoop. That means it can handle trillions of rows easily. Okay, it can handle petabytes of data comfortably. That's the main difference. So we'll go into a lot of detail on this topic, and then you will be able to clearly understand why do we need HBase when we already had RDBMS. Okay, so the second question from Ella is not sure on local mode. Does it invoke HDFS? It does not. Okay, so wherever you are using accessing file, for example, let's say you are using loading a file using load function, not like this, load. There, the file is actually the file in the load. When you say a equals to load, the file one has to be in local folders, not in HDFS. Okay, and we're talking about the local mode. If we say pig minus x local, all right, this is what. Did I make sense to you? All right, there is one question from Yogesh. So Yogesh, you have started the recording. All right. So a question is, what is local mode for? Local mode is only for testing pig scripts without Hadoop. Okay, let's say you have a desktop but you don't have Hadoop, and you don't want to get into overloading servers and other things. So you may want to run pig without Hadoop. Okay, in that case, you can use pig minus x local. Next question from Ila is, when dump statement is issued, where does it save the data until the session is active? Okay, so let me put the question. It's a very good question. So let me say you have load file one. We have b equal to um, filter a on such and such condition, and c equal to say group b by and so on, right? So let's say, and then we say dump c. So her question is that till the point we say dump, right? Where where does it store A, B, and C? Okay. So the quick answer is that it does not store any data. It just takes a note of it that you have executed these three commands. And this note that, okay, C means this, B means this, and A means this. This note is in the memory. Okay, so the moment you say dump, then it will go back and it will try to compose MapReduce after combining all the steps on which C depends upon. Okay. Okay, so looks like my voice is echoing. I think it should be okay now. Ila, is it better now? Okay, actually the default audio was my laptop, and that's why. So do I need to repeat, or was it clear? Great. All right. So going ahead with the next question, let me just so this I hope this is really clear. So this I have answered. If pig minus x local does not use HDFS, do we need HDFS to use pig local? The quick answer is no. All right. A question. Okay. Um, Here, the further question from Ila is dump C stored on HDFS? So dump C just prints on the screen, but if you say store, then it will stores on HDFS. Okay, make sense to you now? Was I able to answer your question, Ila? Great. The next question is from, okay, Yogesh, was I able to answer your question? Okay. All right, let me answer Ravi's question. Question is there any file size limit on pig? File size as in the file it loads? Okay, so let me again make it clear. So when I say A equals to load, it doesn't load it anywhere. It's just a kind of a programming step. It has made a note of it. The moment you say dump C, it's equal to executing the program or executing all the steps on which C depends. So C depends on this, this, and this. because C depends on B, B depends on A depends on load, right? So all of these steps will be combined and MapReduce will be created. Now question is there any file size limit on Pig? So answer is no, because the file size is imposed by Hadoop HDFS, not by Pig. Okay, so as of now, Hadoop doesn't say openly that what is the file size they support. Okay, so the file size they support is a function of memory of the name node and the number of the nodes you have in the cluster. Okay, great. I hope I have answered your question. So any other question before I move forward with today's session? All right, great. All right, so we have to start joins today. Okay, as discussed in the last session, we can join two data set very easily using Pig. So you can say join. Let's say you have two data sets. One is divs and other is daily. We can join daily and divs. And what does it mean by joining? Joining means taking the two data set, bring all the records from both the sides which have the same key. This is the key. We are joining on this key. This key daily dot symbol should be equal to divs dot symbol one. Okay. So what does it mean? So the records from both the sides where symbol is equal will be brought together and columns will be combined. Okay. So if daily has three columns and daily has three columns and divs has four columns, the total number of columns you will get in J and D is 3 plus 4, which is 7. Okay. Next is sometimes you might want to join two data sets based on multiple criteria rather than only two, two values. Okay, meaning two columns from left hand side should be equal to two columns on the right hand side. Bring all such records together and form a single record by combining all the columns. So that's what is join on composite key. So records from daily where exchange and symbol are equal to records from div will be brought together and will be merged into single record. So that is a composite key. Make sense to you? All right. Next is self join. Unlike unlike our usual databases, here self join. I mean, you cannot join a data set with itself. You will have to load the data set twice because at the end of day, loading doesn't equal to loading it physically. It's just expression. It's just a program. It's just expression that you want to load something. The actual loading occurs when you execute something. Okay, so self join are not there in Pig, so you have to do it this way. Let's say you want to join NYSE with itself. Okay, and in that case you will have to kind of load both of them together and then join. Okay, now next question is, what's the difference between these joins and RDBMS join? What is the difference between these joins and RDBMS join? Okay, so the answer is that these join should have at least one column. for joining. You remember the joins in RDBMS where you do not have to have any columns to join on. Okay, so you can join on any even without column. If you say select star from A comma B, that means you are joining A and B without a condition such that all the rows of A get multiplied with all the rows from B. If you have M records in A, M rows in A, and N rows in B, you will get n into m number of rows if you say select star from A comma B. All right. Now, the other important part is joins cannot have conditions. Okay. So you cannot have join A comma B on A dot value greater than B dot value. Okay. And can anybody guess why? Why is it so? Anyone? Ashwin's question is, will it support inner join and outer joins? Yes, it does. That's what we are coming to. Now, all right. The next question from Ila is, in joins, can we specify the columns we want to see? Okay. So you basically, after join, you use for each for projection. Okay. And since the computation actually happened together, right? When you say dump or you say store, then these steps will be combined together. So it gives the similar amount of performance. All right. Okay. So question to all of you is that why is it wrong? Why do you think this is wrong? Why do you think the join should always have at least one column? Anybody? Yes. So that's right, Ila and Alan and Yogesh. And yes, so since a join is converted into MapReduce, the way we were doing the voting problem, and therefore when you do the MapReduce, the way it does the join is by making the columns on which you want to join the two data sets as the key and and then join. Therefore, therefore it is important it's important to know that the pig script, basically the join in the pig script gets converted into MapReduce. All right, great set of answers. Moving ahead. All right, so talking about joins, this is how it looks like. This is how it looks like. So let's say you have two data set, one A, other B. And when you join these two data sets, what you get is this. Okay, so you're joining A and B, A on ID and B on ID. This is the column. And then let's say this is the syntax here, and this is the syntax here for loading A and B. Now, when you join the two, based on this, you get one Sandeep, one Giri, one Sandeep, one Abu, but two Ryan and three Saha do not go into output. Okay? All right. So next question is, what happens in case A1 has duplicate ID and B also has duplicate ID? Okay, so this example talks about that scenario. Let's say A1 is having one Sandeep, two Ryan, and four G, and B is having one Giri, one SG, and three Saha. And if you join A1 and B based on the first column, then you can see that in B the records are repeated. So what you get is one Sandeep. So this record gets merged with both Giri and SG, and therefore you will see two records in output. Make sense to you? All right, great. Similar to the inner joins, you have outer join. The inner join meant where you have records on the both sides, and only then the output is it goes in the output. Sometimes what you want is that even if a particular record does not exist on the other side, we get we should get it in the output. Okay, in those cases you use outer joins. There are essentially two kind of outer joins. One is left outer join and other is right outer join. So what does it mean by left outer join? The data set on the left hand side should, all the records from the data set which is on the left hand side should go to the output, irrespective of whether there is a corresponding record found on the right hand side. For example, let's take a look at this. A is having two records, one Sandeep and two Ryan, and B is having two records, one Giri and three Saha. Now, when we are saying left outer join or simply left join, okay, you can skip outer. If you say left, it means left outer. So you can say when you do a left outer join, all the records from the left hand side will appear in the output. You can see one Sandeep, two Ryan, and in case the record is not found on the right hand side, we have blanks instead. Okay, for one Sandeep, you got one Giri, but for two Ryan, there is no two on the right hand side, and therefore that's blank. All right, now we have right outer join. Okay, although there was no need of having right outer join, you could just switch the locations of A and B and still have the left. Okay, so the right outer join means the data set which is on the right hand side of this comma is all the records from the right hand side, which is B, all the records should go in the output, while left hand side the data could be blank, and if the record does not exist on the right hand side, the data will be blank. Okay, so this is how the left and right outer joins work. Anybody, any answers for this? Quickly. These are very similar to SQL right outer and left outer joins. Okay, any answers for this? Let's say you have two data sets, A and B. A is 1 Sandeep and 4 Ryan, and B is 4 Giri and 3 Saha. We are saying right outer. So, right outer join between A and B based on ID. What will be the output? Eli is saying 4 Ryan, 4 Giri, and then blank blank 3 Saha. Good. Thank you, Alan and Abru and Ila. So Abru, it'll be 4 Ryan 4 Giri, not blank and 4 Giri. All right. So this is the output. You can see 4 Ryan, comma 4 Giri, and then blank 3 Saha. Yes, great. Thank you, Ravi. Yogesh's question is, does it support subqueries? Not really, but we will talk about something called loop within a loop, nested for each. Kulbir's question is, can you please explain why we can't have conditions in pig join? Okay, the reason is that the pig join, the way they are modeled, is after MapReduce. And in MapReduce, whenever you are grouping the two, in MapReduce, the joining of two data set is based on grouping, right? You group after concatenating the two data set, you group it based on the key, and that's how it works. Okay, so if you don't have a way of grouping, if you have a join on based on the condition, then grouping is not possible, and therefore you cannot have condition based joins in pig. A question from Alan is, so is it one pig transformation equal to one MapReduce? Very good question. Can anybody answer this? Yes, anyone? It's a brilliant question. Ila's answer is no. Anybody else? Ashwin's answer is no. Okay. And give me the reasoning as well. Okay, great. So let's take an example for this. Let's say we have A equals to load a file. Okay, we are loading a file. B equals to filter A, and C equals to for each A, something after for each. Okay, and then we have D equals to say group by C. Okay, so you can see that loading, filter, for each. Okay, all of these three steps are essentially cleaning the data, loading the data. That's what we do in the map phase. Along with that, the fourth one, which is group by, okay, which is group by. In group by, it would be internally creating a map reduce, and therefore there will be a mapper side and there will be reducer side. So All of these four steps can be combined into a single mapper, and then single mapper code, and then there'll be a reducer code. Make sense to you? So what does it mean by loading a file? A file is being loaded, which means the way we were specifying an input file in our MapReduce, that's what will happen inside. And then filter, what does it mean by filter? We are going through file record by record and removing those entries which are not useful. And that's a part which we do in the map because we are not doing any grouping, aggregation, or any such thing. Then we are doing for each. For every record, we are testing a condition against it and cleaning up the data. So that's for each. And that again, it just map reduce because it is no aggregation. Then group by starts from here. So group by will have a lot of reduce side logic because group by is essentially map reduce both because it requires sorting on a key. So group by is uh, in group by it will give out the key value and that part would be the key that part will be the mapper part. So all of these steps will be combined in a single step. Okay, so the answer is no. So Ila, Ashwin, and everybody right. Okay, so was I able to answer your question? A question from Ravi: can we do multiple grouping? Say group C, comma B. Yes, we can do that. So question from Ravi is: will it have? Okay, let me just break it down into two questions. The answer is no. This is where secondary secondary sorting comes into play. Okay, all right, great set of questions. All right, brilliant. Now let's move ahead. Okay, keep the questions coming because that's the only way to learn. Okay, so there's something called full joins, meaning the record from both the sides should go in the output. Okay, let's take a look. What does it mean? Let's say you have two data sets, A and B. A has one Sandeep, two Ryan, while B has one Giri and three Saha. Now, two only exist on left hand side, three only exist on the right hand side, one exists on the both the sides. Now, when you do a full join, what happens is those records which can come together, they would come together. That will be one record. Those who do not have a counterpart on the right, left hand side, at the other side, they will come independently. While the other side being the null. So for 2 Ryan, there is no other side, no record on the B. Therefore, the 2 Ryan does not have these two more columns. And similarly, the next one. Okay, so this is called full join. A quick question to all of you. If we are saying join, let's say there are n1 records when we join A by ID and B by ID, we get n1 records. Joining of A, the left join is giving us n2 records, total number of n2 records, and right joining A and B is giving n3 records. So full join will have how many records? Anybody? Yes. So what was full join? Full join was common plus the records which are only on the left hand side plus the records which are only on the right hand side. That was full join. So let's say when you join A and B, and do the inner join, you get n1 records. But if you do the left join, you get n2 records. And if you do the right join, you get n3 records. So how many records will be there in the full join? Anyone? Okay. Kulbir says it should be n2 plus n3 minus n1. Ila says the one regular, one extra in left, two extra in right. Okay, so we are talking in terms of n1, n2, and n4. All right, Ashwin? Yes. So what will be your answer? Abru says n2 plus n3 minus n1. Okay. Anybody else? Yogesh says n2 plus n3 minus n1 by 2. Are you sure that? Yes. This is what Yogesh says. Yes. Anybody else? Prem says it should be n2 plus n3 minus n1. Anybody else? Good. Good. So the answer is, all right, Ashwin says n2 plus n3 minus n1 into 2, and Ravi says, okay, Ravi says, all right, let me try to understand what does it mean. Okay, this is what Ravi meant. N2 plus minus n1 plus n3 minus n1 plus n1. So which is essentially n2 plus n3 minus n1. Okay, anybody else? So yes, most of you are right, and it will be n2 plus n3 minus n1. Okay, so essentially, first you'll in full join, what you get is records which are common and which is n1. Records which are only on the left hand side, and what is that? What does left contains? All the records from left hand side, right? So only on the left hand side means n2 minus common, because left also contains the common one, right? Similarly, right also contains common as well as only on the right hand side. So we right subtracted n1, which is common from right, therefore only right. So only right is n3 minus n1, only left is n2 minus n1, and therefore the total is n1 plus only left and plus only right. That means n1 plus n2 minus n1 plus n3 minus n1, and this. Okay, so this is the total number of records in a full chain. Okay, here is a teaser for all of you. Let's say we say join A by ID and B by ID and say left outer join. What does it mean? Anyone? Good, good. All right, it's actually a teaser question. So it's a wrong syntax. So left or right has to come in the middle. And this one, anybody? Yes, thank you, Ila. And thank you, Prem. So the syntax is incorrect. And this one, anybody? Yes. That's right. It's basically a mistake because outer does not mean anything. It should be either left or right. Yes, that's right, Prem. A question from Ella is, can we assign default values to null fields in any big statement? You can use you can use for each for that. Okay. There's no inbuilt syntax for that. Okay. Sometimes you only want to operate on small number of records. All right. Sometimes you only want to operate on small number of records, and at that time you want to limit to total number of records. In those cases, you can simply use limit and then div and limit then the data set and then the number. Now, problem is that limit only support initial record, but no such thing like give me the last 10 records. Okay, I could not find that syntax so far. If you get some syntax like that, let us know. Okay, next is the sample is something new for lots of people, and sample is quite important. If you have a lot of data, if you have a lot of data and you want to do kind of introspection on the data, and if you do limit, what you get is only initial records. But if you do a sample, you will get random selection of the data, and therefore your your code or your script would be tested properly instead of only on the first record. So sample gives you randomized percentage of the records. So if I say not percentage, it's called fraction. So sample divs point one means give me 1/10 records. All right. Okay. Here is a question for everyone. Let's say we are saying dump twice. What happens to the output? Does the whole map reduce run twice, or does it not run twice and you get the same result? So let's say you have divs equals to load file.tsv, which is tab separated file, sum equals to some records equals to sample divs point one, which means we loaded the data, and then we are saying give me a fraction of it, and afterwards we are saying dump and dump. So if you run dump twice, will it give the same output? Anybody? Alan says different output. Abru says since sample is random set both the times, we will see the output and that could be different. Okay. Okay. Ella says that if you run it twice, second dump will be 10% of the first. Not really, because second dump is again going to be 10% of first one, divs. Okay. Is that the right thing I've understood? Ravi says, I think we'll get different results. Kulbir says same output. Ravi says, okay, since we have a sample random, therefore we will get a different results. Okay, Prem says different. All right. It's actually different. So Yogesh's answer is correct. It might be different, okay? Because it might be that you do twice and there are same random numbers generated, and therefore it could be same, it could be different, okay? But most likely it's going to be different. It's like saying if I throw the dice twice, do I get do I get different values? Most likely yes. Okay, great. Now, as we told you that Pig's basic premise is performance. Therefore, Pig comes up with many nice clauses such as parallel. What does it mean by parallel? Parallel is a way of controlling number of reducers generated in the map reduce that gets generated from a piglet. Okay, so it basically controls the number of reducers. It does not impact mappers. It does not impact mappers. Say for example, daily equals load NYSE underscore daily. Okay. So, and when we say parallel in the group by clause, it'll create parallel with 10 as the number, it will create 10 reducers. It has no impact on the mapper side. Okay. It has no impact at all on mapper side. It needs to be applied on per statement basis. All right. It needs to be applied per statement basis. If you want to apply on the whole script, you can at the top you can say set default parallel, and also note that the upper limit for total number of reducers is 9999. Okay, so 999 is the total number of reducers because it's assumed that you would not have more than those number of reducers, but you can configure it in the pig by having the what do you say the the reducer selection mechanism. You can actually customize that part. So by default, it allocates 1 GB per reducer, but you can customize that because I mean, you can enforce it as per your requirement, but it won't go beyond 999. Okay. So if you do not have parallel clause, let me reiterate. If you do not have a parallel clause, and you are, let's say, churning 20 GB of file, you will get 20 reducers automatically. If you are churning 2000 GB data, which is close to 2 TB, the total number of reducers would be automatically generated as 999. Okay. Yes, it's a performance tuning. So basically parallel essentially controls number of reducers that get generated, so the overall process becomes faster. Okay, a quick question to all of you. How many reducers will it produce? I think you all can answer this. It's quite straightforward for all of you. Yes. So for each, does it have any aggregation? Does it have any group by? That's right. Good. That's right, Ila. It's basically a row level computation. It has no group by, so there will be no reducer. Okay, Yogesh's question is, so each reducer run only on one machine? Yes. Generally, machine selection for reducer running is different machines. It avoids having two reducer running on the same machine. Now, the question to you is, does parallel have any effect in this for each statement? Yes? No? The answer is no. No reducer, so no. That's good. Ila and Yogesh and Prem. Good. Great. All right. A quick question to you is if the data size which you are processing is 2 terabyte, how many reducers will automatically get generated by PIC? Or how many reducers will be executed by PIC? Anybody? Alan says 999. Anybody else? Yes, that's right. It'll be only 999. Okay, I think I've already answered it. Now something very interesting. It would happen quite often that you have to call external functions. Lot of internal functions. There are a lot of internal functions in Pig, but they may not suffice for your requirement, or you have your own organizational requirement for creating certain functions. Now, your question would be that if I have some custom requirement, I will not use Pig and I'll instead use my organization's infrastructure. The question is, if your data is huge and you need to run this computation on large data, then using your existing infrastructure may not suffice. You may have to use Hadoop and Pig. And therefore it's more easy or it's easier to use an external function than trying to get the thing done on your existing infrastructure. All right, is my voice audible to you? Because there is no electricity here. Great, that means internet connection is up. All right, great. Now, so there are there are quite a few things to understand in calling external function. First one is Java built-in. Let's say you want to invoke a built-in Java function. You can simply say define. You can simply let's say there is a function called 2hex string which converts an integer into hexadecimal number, and which is a part of this particular package and this class. So you can simply call this. First, you define it. You give it a nice name, a small name called hex, and then you can use that function as part of your for each. Okay, so what we just saw that we were able to use Java's functions inside big code without any without writing any Java programs. Okay, so this is a quick way to use existing static functions from Java. And sometimes you may want to create your own external functions, basically proper Java classes. In those cases, you can call them like this. So you could use, we will show you this part. You can load your register your own library and then use your class like this. We will show you this part. And sometimes you may want to call your Python function. So you can use Jython and then all the functions which are members of this file will be accessible here like this. So we are saying register this Python program using Jython as bball. We are giving bball the name for this program. Now we are saying for each this particular data set generate name bball dot produce some value. Okay, All right. Are you able to hear me?
Muted.
Okay.
Unmuted.
Okay. Are you able to hear me now? All right. Hello. Okay. Looks like. All right. Since I have shifted my network, therefore I will have to move to somewhere. Okay. Just give me a second. I'll move to another router. All right. Are you able to hear me clearly now? Good. 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 All right. So the next question from, let me see what is the next question. A question from Ella is register session specific? Yes. Every time you execute your code, you will have to register it. All right. Next is, let's define our own UDF function and try to execute those. Okay. It's a very important exercise because this is the way most of the big data development happens. So most of the big data development, the way it happens is you create your most of the script using Pig or Hive. Most of the data churning happens using Pig or Hive. And later on, when you get stuck, when you are in a phase that you can't code certain part in Pig, there is no function available. You create your external functions, you create your user defined functions. Okay, so we'll take you through that idea, because on one hand you have MapReduce, where it takes a lot of hard work to do even basic operations such as joining two data sets, while on other hand you have Pig, which might have a limited vocabulary or limited functions, and therefore may not suffice your requirement, and hence you are happy with none of these extreme cases. So the best way is you start with Pigletin or Hive, and wherever you get stuck and you realize that this part requires coding, you write or you delegate to somebody who is good at coding, who can create external functions for you. Okay, we will take you through how to create external functions. All right, so the project is available here. You can download it. I've already downloaded it, and in the same way you can fix the library locations. Is my audio not clear? Because Ella is saying, can you adjust your microphone? Okay. Looks like it's clear to most of the people. Just that there will be a loss of quality because this other network connection does not have a upload really big upload speed. Okay. Okay. Let me move the mic a little away. I think it'll be better. Great. Okay. So I think the breathing sound was disturbing, so I'm moving it away. All right. So let's say that you have downloaded this project and configured in Eclipse. And let me see if it is there. So the way we configured by importing our MapReduce in the same way you download it, unzip it, and then import it in Eclipse. And Eclipse will find the project in that folder, and then you'll create a project in Eclipse, and then you clean up the library, and everything will be in the line. Okay, so once you import, you will have this kind of a folder structure. So let's take a look at how does a UDF looks like. The most important part to understand is whatever function you want to create in pig, there is an you have to create a class with the same name. Okay, let me repeat. So whatever function you want to create in pig, okay, the functions you want to use in for each, or you want to use in group by, or let's say you want to use in the conditions, then you can you'll have to create a class. Let's say I want to define my own upper function. Okay, so I have to define a class called upper, and then it should extend. This is mandatory, it's a contract from pig that your function, your class has to extend eval function. And here is your data type. I mean, what kind of return value you are going to give in upper. Okay, so if you are going to give string, you put string here. If your function is going to return integer, you write integer here, as in integer, since you can't keep it primitive, so you'll have to say integer like this. Okay, like that. All right, but here, since we are writing a string which can do the uppercase, okay, therefore we will only result string. Okay, so question from Ila is, so we can create UDFs that map to pig function? No, you can create any UDF, whatever you want to do as part of Java code. So here we are trying to define our own upper our function called upper. Okay, it's in capitals. I have kept it purposefully in capital. You can keep anything you want here. Okay, so you can when the most important part is when you extend eval function, you have to override this function called exec. This is the one which is going to get called the moment you call this upper function in the pig. If you call upper function, this exec function is going to be called. Okay, so it's a kind of a contract that if you want to create UDF, please extend it from eval function and and implement a exec function. Okay, now you extend the eval func class and implement a method called exec. All right, so here you go. Okay, a good question from Yogesh. What kind of input that we get from pig command to this Java code, whether it is one column or whole record? Okay, the answer is whole record. So on whatever record you are calling this function, you will get that. Okay, on whatever, whether you are calling it on a single record or anything. So
Okay, sorry. So if you're calling it on one record, one column, it'll get only one column, not one record. Now, why is this confusion? The confusion is that we're passing tuple here. Okay, in Pig, tuple is probably the most basic and most generic data type. Okay, a single value is a tuple, a array of records is a tuple, and so on. Therefore, we pass tuple here. Almost everything in Pig Java library extends from tuple, and anything can be converted into tuple. All right. So let's take a look at what exactly are we trying to say. We are saying in case there is no record or record is null, then do nothing, just return null. Otherwise, otherwise, what is it trying to do? Otherwise, it's basically converting only the first character of the string to uppercase. Sorry, the first record which is passed as to the uppercase, and putting double dashes around it, putting a dash, two dashes around it. Okay, so and once you have finished coding your function, we are trying to achieve, okay, whatever we are trying to achieve. If we are done coding that, then we can export it as a Java jar, which is the standard way of creating any Java library. All right, so we are saying finish. All right. So a good question from Ila. So while grouping, what kind of input is passed to Java? Okay. So let's say we have A equals to group, let's say A naught on ID, and we have another function which is B equals to for each A. Okay. For each A, and then we say generate my func A. Okay, this is what we are trying to do in this. So the question is, what do we get in my func? Okay, so if there is a function here which gets called my func, okay, what is the data type that get passed here? So what will be here? It will be still tuple, and what you can do is you can say if type of input equals to map, or you can say map, then you can cast it to the map. All right, you can cast it to the map, and that's how it works. All right, so essentially you can cast this tuple to whatever data type you are going to process. Did I make sense to you, Ila? No. Okay. So sorry, it'll be actually when you say group by, it'll be a bag, not map. That's right. So yes, it'll be same for bag as well as map. A tuple can be casted into a bag or map. You could say here, in those cases, you could say here bag. Okay. Okay. And all right. Hey, can you check if the net connection is working on no big data or a dot no big data? Now Airtel is also gone. Hmm?
Muted. Unmuted.
All right. So I think my network connection again fluctuated. So there would be a delay. Unfortunately, both my network connections are fluctuating today. Are you able to hear me now clearly and see my screen? All right. So we were talking about this. Okay. So here, okay. So once you are done, you can do a file export. And in our case, we have already finished exporting the files. You can see pig.jar has been created. Now upload it. Let's upload it to my console. For that, I'll have to open my LMS to get the password. Okay, I'll answer your question, Ashwin, in a minute. All right, let me open. Okay, so let me open first Hue. So instead of using SCP or WinSCP, I'm using file browser here, and then I'll do Hadoop CP. That'll be quicker. Because this file needs to be in the local file system, not in HDFS. Okay, so let me open my console as well. Okay, so I can say I opened pig. I could actually say copy to local pig.jar. So I'm copying the pig.jar which we had done there, uploaded in the HDFS, and now I'm saying register pig.jar. Okay, has it been exited? Let me see. ls, that's correct. Okay, so we are saying register pig.jar. Okay, essentially I did not have to use double quotes. That was the mistake I was making. And all right, now let's say we are saying something of this sort. So we are saying load some file called A, and then we are trying to load some file called A, and then we are trying to call my function called upper, which was in a package called myudf. You can check that. So you can see at the top, the package name was myudf, and therefore we are calling it that way. And then we are saying dumpy. Now let's check. See, so if you see the content of A, you can say content of, where is that file? Content of data slash pig. If you say cat data pig, it has these records, right? So, and when we said for each and we passed the whole record, right? When we said for each and we passed the call, not the full record, we just passed only the first record, right, out of this column. Then it basically it capitalized A and put dashes around this. Okay, that's what the Java code was doing. If you look at it, we are putting dash around the word and converting the the whatever record which we found into uppercase. Okay, made sense to you? So this way you can actually define any kind of function using a full-fledged programming language like Java, because Piglatin is fairly, you know, the library is quite small. Okay, there was one question from Ashwin that if we execute for each loop in Pig, then Pig will call Java class for each element of the Pig. So it will basically instantiate it only once. That's the reason it has a class. So it instantiated this class only once, but on that object of the class, it'll keep on calling this exec method again and again. That means, since in Java, the biggest work gets, okay, so the biggest work gets done as part of upper, okay, biggest work gets done while loading the class. Therefore, it loads the class only once and execute this exec method many times. Okay. Yogesh's question is, can you please show us example of capturing whole word, whole record? Okay. So what if, let me ask you, what if we try to execute the same function on, let's say for each generate on, okay. So let's say we say call and column 1. And when we say dump B, what kind of error do we get? Okay, so let me see if there is a file called data pig B. Okay, do I have C? Or let me try to load, let us say, data mr word count and input slash big dot txt. So here the full file will be loaded as a line. B equals to, let me just try to do that. Let's see what happens in this case. Okay, so since the whole line is essentially a full record here, it has converted into the full, uh, I mean, a big, into uppercase. Okay, so I'm actually wondering how can I show? Okay, the best way to show would be, let's say A is some load, B is group A by C, and how can I? Okay, okay, all right. Mm, all right. So Yogesh's question was this. So let me essentially the baseball one example. The baseball example. Where was that? Okay, let me try to do it. All right, let me try to load the baseball example. Okay, okay, this is good. Now, I basically, yeah, this is what I'm looking for. Okay, so here the team is bag here, bag, and this is a map. And then, okay, let me try to do this. So let me just try to say dump b-ball.
Okay, let it come up and finish. So I'm trying to do this right now. I'm trying to load it, and then I want to say, so which field is this? This is a tuple. It's a bag of tuples. The unfortunate part is that there is no tuple as such here. Okay, let me come up with another example when I got some time. Okay, let me come up with a better example. Right now, I'm not able to come up with a better example. Okay, so let me tell you the general theory. So anything can be casted into the tuple can be casted into anything. So if a map is coming to you, so you could always say there was a map, not this one. So there is a map. What do you call? From the pig, there should be a map. All right, let me come up with a proper example. I think right now I'm just wasting everybody's time. So let me come up with a proper example. It's a good question. So yeah, all right. The only reason I have put in here the conditions like input dot get zero is because sometimes the input comes as a record. Whatever input you give, whether it's a single column or anything, it always comes as a tuple. That's why I have put in get zero. All right, so let's do it at some free time, and then maybe in the next session we'll discuss that. All right, now let's go ahead. All right, now so we were able to we were able to use our upper function successfully. Okay, so make sure that you try to run this project because that will be very important. Even if you do not know much of a coding, still you should know how to compile and run a big UDF. Okay, all right. Now, sometimes you have some legacy code which is not neither in Python nor in Java because the way we did with Python, Java, we could also have done with Python as described earlier. But sometimes you have no control over choice of programming language. Okay, and it's not a standard Java code. In those cases, the way we used Hadoop streaming, we could also use pig streaming, meaning streaming data through a command instead of a UDF. Okay, so let's say, for example, here we have a Perl file. Let's say in your organization there is a lot of code which is in Perl. So how would you run it? It's not in Java or Python, therefore UDF is not possible. But good part is that Pig provides you this streaming, whereby the way you do is load the div, then stream divs through this data. Stream this data through this program as this. Okay.
Okay, so what does it do? And also note that it's a backquote. It's not a single quote, it's a backquote. The one which is before one in your numeric keyboard. And I mean, on the number pad above tab, you will see this backquote. It's a backquote because this allows us to have double quote inside backquotes. Okay, so you can simply call any program inside your Hadoop, inside your pig streaming. Sometimes this command may not exist on every node. In those cases, you will have to ship it. Okay. Also, you can also pass the argument to this command like this. Okay. So you could say define HD, which is this command, and please ship this file to all the nodes before executing this command. Okay. So you can use this function as if it's a pig function now. So we could say stream devs through HD. You can say stream data through HD, and the result will be converted into this format. Provided the data which this is outputting is tab separated, you will have this. In case it's giving comma separated, you could say here using pig loader and comma. Okay. So this is the way you can execute any legacy code with pig. All right. So we'll talk about piggy bank after the break. All right. So we will have break for 10 minutes and back by 9:44 p.m. IST. All right, so let's start. Okay, so let's start. A question from Ella. A quick question here is: won't you need to code it to get a record or a loop for each? You will have to code. I think you're referring to this part. Are you referring to the streaming, or all right? So okay, I think she's not back. All right, we'll discuss it later. Okay. Yes, you will have to code it back. So in case we are dealing with map instead of a tuple. So by default, in the upper, you get a tuple. It assumes that the column's data type is a tuple, not string, not integer. It's a tuple. So therefore, we are saying tuple dot get zero because zeroth element of this tuple is actual value of a single column. So that's why. Okay. So yes, you will have to make code changes if there are different data types you are dealing with in your UDF. Alright, so we are talking about the streaming case. So you can actually stream any data through any command via pig. Alright, next was the piggy bank that we talked about. We were about to talk. So in the piggy bank, there are many people across the globe who keep on contributing their code, and all of that becomes part of piggy bank. There are many UDF functions which keep on coming. For example, parsing XML, parsing JSON, parsing CSV file, proper CSV file, as in the Excel kind of format. So there are there are many people across the globe who are using Pig, and they have also developed these UDF. So most of this is contributed back to Pig's repository and is available in the SVN repository provided to them. Okay, so if if you have a requirement of certain special Pig function, you might want to check this URL first, and then there you will see all the listed functions and the library UDF available to you. So you could basically check out the pig repository code. First you create a directory pig, then change to that directory, and then check out the code from using svn, and then using ent you build the project. And once the project is built, the output will be in this directory, and then again you can build the piggy bank, and afterwards you will have piggybank.jar file in your directory. Okay, a little older version of piggy bank is available in slash data slash pig folder. Okay, you will have to copy it to local before you can register. All right. All right. So you can simply, the way we registered our pig.jar, similar way you can also register the piggy bank.jar, and then you can use complex functions available via piggy bank, such as Excel, CSV Excel format, meaning the CSV format. There are many CSV format. One of them is promoted by Excel. So, so that format you can use from the. You can parse that kind of data using the piggy bank library. All right. Now we have question from Ashwin. If we have more columns in a tuple, how we need to do like this? Yes. Or you can iterate using a for loop. Okay. A quick suggestion from Ila. Can you go through this hands-on for 5 minutes? All right. Let me try to show you. Okay. So we could go to pig. There is no pig directory. I'll say make directory. Piggy bank. Okay. Then I go to piggy bank here, and then what do I do is I check out. Okay, so it'll take quite a much time to check out. So it's downloading all the code from Pig's repository. Okay, so it'll take some time to download the data. All right, it may take some amount of time. So essentially, I have tried to check out this project. I just copy pasted this command, and then it started downloading all of that. Now once that is done, I could simply say and it'll keep on building the code, and it might take some good amount of time. Okay, it's going to take a quite much amount of time. Once you are done with it, you go to this particular folder and then again run this command. Okay, all right. So I think it'll be taking too much time right now. So we'll do it some other time. Or you can try it by yourself. All right. Okay. So once you have done that, this jar you can easily you can register this and get going. Okay. Next is yeah. All right. So here is a quick problem to all of you. Let us say you have two column data, as in a data set that contains only two columns. First column contains the name of the city, and the second column contains the name of a person. Now, what you have to do is you have to find distinct names in each city. Count of distinct name in each city. For example, the distinct names in Bangalore are Sandeep and Vivek. Therefore, it's two. While in New York there is only one. So, given this kind of data set, How would you find count of distinct names in each city? Anybody? Based on what we have learned so far? Yes. Okay. Yogesh says you just group it by city and name. That's very good. Okay. Okay. Good. Good. Yes. Any other answers? Okay. All right. So such kind of problems are difficult when you have to iterate over a map in the field, right? If one of the columns is itself really big map or really big bag, you might want to iterate over the values of this bag. And in such cases, for each nested comes into play. So, what does it mean by for each nested? Okay, so you could have for each within a for each. So for example here, what we're going to do is load people, then group the people by the city, and then you iterate over every group. You say for each group, and then all the cities or all the people inside that group. Okay, again you basically operate on that, considering that as a new data set. Okay, considering that as a new data, the way you're operating on people here, which is a data set, similarly the group for each of the person will be operated inside this for each. The magic is done by these curly brackets. So when we say distinct is applying on the people. Okay, also at the same time we could have another for each inside this for each. Okay. Yes. So we could have another for each inside this for each. Okay. So this is called for each nested, specifically for the cases when the fields itself have a big bag of values which need to be iterated. In those cases, for each comes to for each nested is quite useful. Next is the fragmented join. This is very important aspect. So let's talk about a situation, a problem. Okay. So the problem here is, let us say you have a file which contains name of the persons along with the country name, country prefix, you can say, two letters country prefix. Okay, and these are billions of entries. These are billions of entries containing name of the person and the country prefix. Now, what you have to do is convert this country prefix into the ISD code. Okay, what you want to do is you want to convert this country prefix into an ISD code. Okay, for that you have another file which contains this mapping between the country and the ISD code. Now, question to you is, if we do the standard join between the two, do you think it's going to be very intensive? Or do you think that is there an alternative to doing the join in the standard way? Can we optimize this kind of scenario in any way? Imagine that you had to write a map reduce for this situation where one file is in the size of few gigabytes and the other file is in the size of few bytes or few kilobytes. So to join such kind of data, do you think using MapReduce, do you really need reduce phase? Can we optimize MapReduce for such kind of scenarios? Anybody? Alan says that I would want to ship copies of a small file out to the nodes. Brilliant, brilliant. Thank you, Alan. And then, yes, so that's what I would also do. I will just take the second file, okay, ship it to all the nodes, and then the way using minus file option, I would ship it to every node, and then using the Java file command, I'll read this file and load this data on every node in the cluster. And then in the map, while we are iterating over these billion entries there, just translate the country code into IST code by maintaining the second file in the memory and iterating over the first file on different nodes. Okay? Yes, that's good, Abru. We may not need reducer if we can do right outer join first and filter. Okay, but if you do the right outer join, you will again have the you will have the reducer phase. So did I make sense? So in this kind of scenario where you have a huge data, one file is really huge and other file is very small. Okay, so the joining, the way the joining happens is joining involves grouping of the data. So the data from both the sides will be grouped, combined and grouped, and then the records are brought together. So in that case, there will be sorting, there will be reduce phase, and so on. Okay, but since the second data is quite small, we could just load it in the memory, and in the map phase, for each record, we could just look up in the memory and then translate the country prefix into IST code. Right? Is everybody with me? The same thing can be achieved using pig by using something called replicated join. And this is how it looks. It's quite straightforward. All you have to do is, while joining these two tables where one file is really small or one table is really small, in that case you could just say using replicated against the second data set. We are saying join persons by country and CC by country using replicated, meaning the second data set should be copied to all the nodes and then joining should happen. Okay, so this is another optimization step provided by Hadoop for you. All right, next is joining skewed data. When you have Too many keys, uh, okay, too many values for certain keys and too few values for certain keys. That means the data is skewed. That means the data is skewed. So you tell pig that be aware that my data is skewed, and hence and hence take the step accordingly. For example, in our first word, second word kind of scenario, the one which we discussed about word recommendation, there, if there are prepositions like if, uh, the articles and prepositions which are very common, so the words that follow them will be in millions, and therefore there is a skewness in the data. Certain words will have only few occurrences while certain words will have occurrences millions. Okay, to optimize such scenarios, if you could tell pig that hey, my data is skewed with respect to this particular key, so pig will take the right steps in the beginning itself. Okay, and how does it take the right steps? By using the secondary sorting. Okay, all right. Now, there is one more very interesting step provided by Pig. It's called joining using merge. Let's say you have two data sets and you are very sure the column on which you want to join, the data is already sorted, right? So, to avoid Hadoop from sorting the same data again, you could say join the two data set using merge. Okay, join the two dataset using merge. MapReduce itself provide this feature that we could tell Hadoop that my data is already sorted, so it won't sort it again. Okay, imagine that you are operating on certain data. The output result of those operations is already sorted. Therefore, you don't need to sort by the same key again. All right. Therefore, you could tell Hadoop that hey, my data is already sorted. Okay. All right. So it's quite often that when we deal with data, in the first step itself, the data got sorted, and the second step, we are again joining. Okay, so let's take few cases where we have two files. We want to join the data and group the data. We want to join the data and group the data on the same criteria, on the same column value. Okay, in those cases, co-group is very useful. Okay, co-group two tables uh, essentially means that we first group the tables by the same column and then join the two tables based on those same columns. Okay, for example, here we are co-grouping by owners by animal and pets by animal. What does it mean? When we first, both of these data sets will be grouped together. For example, Adam cat and Alice cat will come together and then they'll be joined. That means Alice cat, Adam cat, and Paws and Whiskers. They will come together in a single record. You can see that? So the name of the animal is the first field of the tuple, and this bag contains all such records. All right. Now, just like any databases, we have union here also. Here, union does not mean the kind of C union we have. Here, the union means we have two data set and we want to concatenate those two data sets. If you want to just put one data set on top of another, okay, you can just simply say union A comma B. And what does this do? It essentially prints all the record from A and then followed by all the records from B. It's not like join. There's no joining happening. It's just printing the data to the screen in this manner. Or just concatenating two data sets. It's equivalent of saying cat A comma B, cat A space B, which means concatenate the two files. Similarly here we are concatenating two data set. Now sometimes you are concatenating two data sets which might have same columns or which might have similar schema. So you would like to have the data of the same column under the same, okay, data from same column from the other data set should appear in the right place. Okay, so in those cases you could say union A and B, but respect the schema, meaning union on schema A comma B. Okay, so this diagram will make it more clear. Let's say you have A, B, A has X and Y, while B has only Z and X. So you can see that A and B have one column common called X. Okay, and when you union the two A and B, okay, you will simply get the data from one and then followed by data from the another. While if you say union or schema, it will create three columns because there are three columns X, Y, and Z. Under X, all the data from both the records will appear. For example, B12, B22, and then A11, A21. Okay. Second is the records from Y. Y. So the records from Y, there are no records for column Y in B, therefore these are blank, and there are no column, though there's no values in A for Z. Okay, therefore this is the result. So it basically respects schema. Okay, a quick question to all of you. Yogesh's question is union schema like full join? Not really. Not really. Full join brings record together based on certain criteria. Here, it's not like that. Here, it's more to do with the columns. Okay, it's more to do with the columns. It basically concatenates the two records A and B. Okay, or let me ask you this: if A had 20 records and B had 30 records, how many records will union have? 30, 30 plus. So if A had 30 records and B had 20 records, the total records will be 30 plus 20. Similarly here, 30 plus 20, which is 50 records. Okay, while that's not true in case of full join. It is essentially concatenating two data sets, just that it is trying to match the columns. It's trying to match the columns, their names and their, yeah, essentially the names. All right. A question to all of you. What happens when we say join A comma B? Anyone? Yes. So by column name is missing. That's right, Ila. So the syntax is incorrect. Okay. But if you want to do the same thing, if we say in SQL, if we say select star from A comma B, is essentially a cross product of A and B. If you have to achieve the same thing here in pig, you can achieve the same thing using another keyword called cross. So it basically does the cross product of the two data set. Okay. All right. So since pig is generally used in case of report generation or doing the analytics over data, therefore it's quite common that we might need to run the same pig script every day with different parameters. Okay? Maybe you want to run it for today, you want to change the date, and so on. Okay? So in these circumstances, it becomes imperative that the we would like to have the parameters to the report. And it's a standard feature with almost every analytics engine to have the argument or the parameters to be passed to it. Okay, so you can have the parameters like this. You can say $date. Okay, and this will be substituted with whatever argument you pass on the command line. Okay, if there are too many arguments to pass in the command line, you can keep these arguments in a separate file, and in this separate file you can refer other variables in it. All right, so this way you can pass this parameters file on the command line argument. All right, so pig also provides something called splits. It doesn't matter much because you can achieve the same thing using datasets. Okay, so you can split a dataset into multiple arms. So for example, we are trying to split wlog into three dataset: April 1, 2, and 3. Okay, and here we are putting various kinds of conditions. Now the important part to note is there will be some records which may not go in all these three arms. Okay, in any of these three splits, there will be some records which will not go, but there will be some records which might go on both. So split is not really like a split. It's more like generating dataset from an older, bigger dataset. All right. This one we have already discussed. Okay. So as somebody has already asked that will one map correspond to only one transformation? The answer is no. One map will compose of many kind of operations. Similarly, one reduce might have multiple operations. Okay, so pig tries to combine multiple groups and filters into one, and also creates multiple map job depending on what is it that you're trying to do. Okay, so basically there is the other important aspect is there is no linear execution, meaning unlike, let's take a look at this particular line. Okay, let's say we have a A equals to load X, and we have B equals to load Y, and we have C equals to for each A, and so on, right? So you can see that the execution is not linear. There is no guarantee that B will get executed. So if I say dump C, it will execute A, it will execute this one, and it will execute this, but it will not execute this one. Okay, this is called non-linear execution. Unlike our programming language where the control falls from the top to the bottom. So this one get executed, then this one, then this one, and then this one. Okay, but this one will not get executed. Okay, so this one will get executed, this will get executed, this will get executed, but this will be skipped. So you can see that there is non-linear execution. Okay. Okay, one question from Ila. So what's the point of condition in split? It will, if it randomly distribute. No, it won't randomly distribute. Okay, it will follow the condition. Just that the way we visualize split is that if a record has gone into this, it may not go into this. If this condition says that the record should go here, it would go here. Okay, so a record could go into multiple legs depending on the condition, and record can be skipped based on the condition. Okay, okay, makes sense to you now, Ila? Did it make sense? Okay, so based on the logic, the condition, a record could go into multiple leg if multiple conditions are satisfying. Okay, or if none of the conditions is satisfying, these are the conditions, right? If conditions. If none of the conditions are satisfying, a record might drop out. Alright. Now there is an important comparison that I would like to make here between Pig Latin and SQL. SQL is coming up, so let's try to understand the two. So in Pig Latin, user describes exactly how to process input data. You must have seen by now that we are writing the code in stepwise fashion. Load A, clean A, and then after cleaning do these things and so on. So in Pig Latin, we write the steps to clean up and process data. While in SQL, while in SQL, we write a single query to get everything done in a single shot. So in Pig Latin, you see a long series of data operation. In SQL, that's not the case. Next, Pig Latin was designed bottom-up for distributed or parallel computing, while SQL was designed for RDBMS, Relational Database Management Systems. Pig Latin can be used when the schema is not very well known, while in RDBMS, we basically create very rigid structure of tables. If the data is not fitting in those, it'll take it'll take some time, it'll take a lot of processing to format it and then process it. All right. Okay. So there are two questions right now. One question is from Ila that so but it will go in a linear manner of dependency. Okay. So in the way we are describing here, or let's say here, it's a yeah, you can say that it's kind of linear. It's just skipping and hopping, right? But we don't call it linear because it's jumping the steps. All right. And also there is no one-to-one relationship between a transformation and a MapReduce. A question from Ashwin, but it will go in. So question from Ashwin is, Can pig be used for NoSQL? Yes. All right. So Ila, was I able to answer your question? Okay. Abru's question is, it's not linear because things are happening in parallel. Is that a good way to understand? So yes, that is one way to look at it. Second way is that multiple transformation will club into one mapper, and multiple reduces will be happening through uh, multiple transformations will be combined in reduce as well. Okay, so that means it's not necessary that a filter command which the filter commands which are executed in certain fashion in the pig script will be executed in the same fashion in the MapReduce. Similarly, based on dependency, yes, but this is partially correct, that if you have dependency from top to bottom, the execution is also from top to bottom, just that there'll be skips. Yes. All right. Abru is saying that step A and B could be happening at the same time at different nodes, provided we are running the similar commands. All right, that's a good point actually. So imagine that we have A load X and B load Y, and we are saying C equals to join A comma B. Okay, we are saying join A by ID and B by ID. Okay, so this load A and B might be happening parallelly in the network. So there is no straight correlation. So question from Ila, load A, load B join filter will be sequential? Kind of will be sequential, but not always as per the real execution. Okay, so that was about pig. So feel free to ask any question about pig and also go through the exercises of pig. And if you want to go into the detailed documentation, go through the general docs as well as how to create custom library functions. You can go to this 0.13 version. All right. Okay. All right. Now we would like to continue our discussion on Hive. All right. Any questions before we continue with Hive? No questions. A question from Ila. As we go through Hive, can you please point out the differences between Pig and Hive where applicable? Sure. Yes, Ritika, you have a question for me? Okay. All right. There are a few questions. Let me. Okay. Now I can see a lot of more questions. Somehow all the questions came together. Wow. There are so many questions actually. All right. So, okay. Ashwin's question is, if it is used for NoSQL, can we execute pig command in Cassandra and MongoDB? I know about Cassandra, but I'm not sure about MongoDB. They allow loading data from Cassandra. A question from Kulbir. Can you please give an example of Pig Latin where schema is not known? Okay, so for example, even in our case where we simply loaded, say A equals to load data mr word count and input slash big.txt. In this case, if you look at it, the schema of the data is not known. It will essentially create a single column data set. Okay, and then you can parse it here. You can do ETL, extract, transform, and load using pig. All right. So Ritika's question is documentation for hands-on stuff. It's actually done. It's actually done. And let me check why it's not here. So one is this hands-on guide. Ritika, are you able to see hands-on guide here? Then, okay. Alright, looks like. Okay, I need to check why the rest of the hands-on guide is not yet updated. You have Hive hands-on guide. You have, okay. All right. So yeah, there are a few more. The hands-on guides are coming in, so we'll put that. The project problem statement. Okay. So one of the exercises that you have to do now is with respect to the pig. Okay. So the subjective question, just please go through the subjective question. So it basically is a very good exercise whereby you will learn how to parse data and how to do the matching using pig. Okay, the project statement we will describe in the last session. Okay, Ashwini's question is, where is last Saturday's next word recommendation project? It's actually part of it's actually part of the session 4. Yeah, here in this one. Okay, and this one. All right, you'll have to download that data. Okay, good. So, any other questions before we move forward? Right? A question from Ila. Will we go over the previous projects and what was the best option for each? Mm, okay. All right. So actually, the exercise there are. If you do the pigs exercise, there is one section where you have to do all the exercise which we have done for pig in MR, and that will actually convey clearly that what should be done using pig and what should be done using MapReduce. All right. Okay. Good. Good. Any questions at this point, or move on? All right. So let's start with our Hive discussion. So Hive is great and Pig is great and everything, but the question is how to move existing developers and existing infrastructure onto Hadoop. We cannot say that we cannot say that your SQLs need to be translated into Pig Latin and only then you can work with Hadoop. Okay? And there are many people, probably almost everybody in the industry, would be knowing the basics of SQL, right? But not many people would be knowing Pig or MapReduce. MapReduce is even difficult for senior developers, so is very error prone also. Therefore, MapReduce is not always a solution. You generally look forward to some cousin of SQL. And keeping that in mind, the Hive was created. Hive is essentially an engine that converts SQL into MapReduce underneath. All right. Just like Pig converted Pig Latin into MapReduce, Hive converts SQL into MapReduces. So you can actually use SQL to churn most of the big data via Hive, and we will see that in this session. Okay. So the value proposition which Hive brings onto the table is it's most suited for data warehouses where relatively static data is analyzed and we do not require fast response. Okay, and the main value proposition which Hive brings to the table is that you don't have to rewrite your SQL. Okay, it makes very easy to port existing SQL projects. It provides a SQL dialect called HiveQL. Okay, and it meant so to achieve this, to achieve what data warehouses need to achieve, it has something called metastore. We will go into the detail of metastore soon, and it allows querying HDFS file and HBase. Okay, so when you have to process use data which is fairly static, then Hive is the solution. All right. Now, there are few limitations that we need to know. One, it does not allow record level edits. Although in the recent version of Hive, they have update insert and delete, but still that is in quite a development phase. So Hive does these days it has started providing, but classically it was not meant to provide any editing options. Okay, it was more of an analytics tool. So using Hive, you cannot edit records, update records, delete records, but you can create new tables. It's not suitable for OLTP, which is online transaction processing. Why? Because it converts every query into MapReduce, and therefore it could be quite time consuming and may not be suitable for OLTP since it converts everything into MapReduce, and we know that MapReduce is slow, and therefore Hive queries are slow. All right, this diagram will give you more idea about the ecosystem of Hive. So the heart of the process is driver. This driver converts the query into MapReduce and get it done through yarn, or you can say through Hadoop. It gets executed that MapReduce via Hadoop. Okay, so the driver converts SQL into the real MapReduce code. Okay, now around the driver there is something called metastore. Okay, unlike pig, where we said a equals to load something and we provided the column name, we provided the data structure. Every time you log in into pig, you start the shell of pig. You have to start from the scratch. There is no way of memorizing data, right? No way of memorizing the data structure of the data set. Okay, so every time in pig, every time we have to say load such and such with this column name, this data type, and so on, right? In case of Hive, that problem is solved. Hive comes up with a small data store called metastore. It stores metadata about metadata about the the tables or the data you want to process. Okay, so the driver coupled with metastore is what Hive is. Okay, now how do people interact with Hive? One is using command line interface, second is Hive web interface, or you can say Hue, and then you have thrift server via which we can access via Java. Using Java we can make call to the driver, okay, using JDBC. You remember in JDBC or ODBC we could execute SQL query, and the results whatever we get we basically can. Okay, so we can, if you are using JDBC, we can essentially run any data, access any data via our Java code. Okay, if you have ODBC, you can access any data through the Windows machines, and therefore these connectors, this layer of connectivity, makes Hive very much acceptable. Okay, so this is pretty straightforward. The driver is the heart of the system, which converts the query into MapReduce, and driver uses metastore because in metastore it keeps the data, the column types, number of columns, and so on. All right. The last question is, for Metastore, is MySQL standard for Hive, or it can be any DB of choice? It can be any DB, but by default it's MySQL. All right. So to get started, you could use hosted CloudX Lab. So you could simply do two things. One, use the Hive from the browser or Hive from the console. Okay. So you could go here. Okay, my token has expired. All right. So either you could just say Hive here, or you could open Hue and go to Hive. All right. So this is my Hive, and here I can create database called, let's say, SG. Okay, so we have to say SG. It says already exists. Okay. Okay, so I could say SG4 and start using that. Okay, so what I've done is I've logged in into Hive, and then I've created a database. I'm using that database and showing the tables. All right. Same thing I could also achieve from here. I can refresh the list. So I can see DB SG4. So there are no tables as of now, but we could create a table here. We could say things like create table from here. Okay, so the table must be created. Yes, X has been created. We could say create table X and then column name. Okay, select star from X. So you can see that there are no records and so on. Okay, now let me just delete it, drop table X. All right. So that was our quick query on Hive. I can exit from here. All right. The last question is, if I start fresh at console, how will I see tables in my schema? Okay. You don't have a schema by default. You'll have to first create database and your DB, whatever database you're. Okay. A question from Ashwin. If you're using Pig in Cassandra server, how will Pig MR in Cassandra? Okay. So generally there will be a data transport. Okay, Prem is suggesting that can we do rest tomorrow? Sure, we'll do the rest tomorrow, but yeah. So everybody is able to create their database either through the Hue web interface or through the console. Create your own database so that you have a pristine place to work. All right. So we could drop the table. Did we drop the table? Yes. All right. So Eli is saying that since there is time, you could quickly go back to piggy bank for those who are interested. So I've gone back there. I have started the compilation. Let's see if it finishes. By that time, I'll try to answer your questions and we'll try to do a little bit more hands-on. Okay? Or in the meantime, you could also go through this query. Okay? So what we are trying to do is first we are trying to make a copy of this file. Then we are creating a table on top. We are creating here table and then loading this file from HDFS into our table. Okay, that's what we are doing in Hive. And then we are saying select star from docs just to test it out whether it's happening or not. Okay, then you could create a table word count and here after you have split it, if you explode, that means there'll be one word per line and then you can group by and count. All right, you can try these two examples. Okay, all right. So Ila, that ant is still taking a lot of time and let's just wait what happens. Okay, I created database schema, quit, go back to Hive. Now how do I see my table there? Okay, you could say use your DB, okay, and then say show tables. If your DB is empty, then there'll be nothing in show tables. All right. So just like pig's command prompt, Hive also provides you command prompt. You can run HDFS commands from the Hive interface as well. You can load an external Hive script using source command. Comments start with double dashes, and you can set variables in Hive as well, just like parameter variable in Pig. Similarly, in Hive, you have environments. You have environment variables. All right, and then there are various kinds of data types. All right. Yes, Ashwin, you have a question for me? A question? Yes, I can see the question now. Okay. Question is, if I created database schema, go back to Hive, now how do I see tables there? Okay. Is that your question? So after you have created table, are you able to say show tables? Okay. Another question. If Hive is using RDBMS DB, then for record of use, Yes. So Hive is only using the RDBMS for metadata, not for the complete data. And what is metadata when it comes to Hive? Metadata means the name of the tables, okay, name of the columns in a table, and so on. All right. So that's pretty much for today. Let's continue from here tomorrow. All right. Thank you very much and have a great day. Data will be in HDFS, yes. All right. All right. Eli is saying that for piggy bank, per the instruction, we can use piggy bank jar that exists. Can you go over the steps for that? All you have to do is what was written there? Where is that instruction? All right. So here, if you go to the subjective test, there you have to copy to local. I'll show you how to do that. So you could say run pig. Okay, I'm running pig, and then I could say copy to local and this folder. Not here, not here. I'm running it on my desktop. Okay, let me go to the console. Yeah, this is my console. So I could run pig, and using pig itself, I could copy the things to local. Okay, so I could say copy to local this. So it has copied my piggy bank dot jar to local. You can also do the same thing. Okay, you could say register and then piggy bank. So now it's registered. All right. Is it clear, Ilana? So Ila's question is, how do I see the code in Eclipse? You can't see the code in Eclipse if you're using piggybank.jar, but you can import the project which you have downloaded in Eclipse like this. File, import, and then you could go over the existing projects in Workspace. And then there was one folder which we created that was in my home folder. It's called piggy bank. Okay. Now if you do the piggy bank here, you could just, you can see that there is a project, and then inside here you will see all the code. All right. No, it's something else. Okay, so let's just import. All right. So basically you can just browse the code here if you are not able to configure. Okay, you could just go through the code. All right. So I checked out in here in earlier here. So just use the command, that should work. All right. That svn checkout, the command which is given in slide, that works fine. So please use that. All right. Use notice that there is a dot at the end of it. All right. Thank you very much. Have a great day. Bye bye.